Okay, so the last time, sorry, the video got disconnected for some reason. So we came to the point now, they could ask you to make a conclusion. So we defined the parameter here. Now we're ready to make a conclusion. To make a conclusion, you can either base it on strength or base it on significance. You do this if alpha given. So if you don't have alpha, so you have to base it on strength. We have alpha, I gave you alpha of 5%, so we have to base it on strength, on significance. Now here, if your p-value less than or equal alpha, so reject H0, conclude HA. P-value more than alpha, do not reject, and H0, and do not conclude HA. So your p-value is almost 0%. That's less than 5%. So we're here. We are rejecting H0. We are concluding HA. And since we discussed the assumptions, now we say since assumptions hold, or we still say F because one of them doesn't hold. So if assumptions hold, and since we're using significance, we can say at 5% level of significance, we can conclude HA. But instead of HA, you have to put it in words. So you can conclude that the mean is more than 20 years. So we can conclude that population mean age of first marriage in years for all women, or for the population of all women in this city, is more than 20 years. So this is if you, so I took the question, and the same question, we did it as confidence interval, and also we did it as hypothesis. So this first question, question 2. So the non-exercise activity, thermogenesis or whatever, it's called the NEAT, N-E-A-T, provides a partial explanation for weight loss without exercise. So NEAT is an energy burned for fitting, maintenance of posture, spontaneous muscle contraction, and other activities in their life. Recent study, you have 16 subjects. They're measured for 1 week at the base food consumption level, and then again at a higher food consumption level. Their average increase in NEAT was 3300 per day in response to additional food, and their standard deviation was 250. Now the question A, explain why you would use a t-test rather than a z-test to do this problem. So t-test versus z-test. You use a z-test if sigma given. Use a t-test if sigma is not given. Now, what is sigma? Sigma is standard deviation of all. In this case, you have 16 subjects or 16 people of all subjects. So, of everybody. Now, they tell you at the end of the question, you have a standard deviation. The question is this 250, is that S or sigma? Well, is this standard deviation 250 for the entire population, or is it only for the 16 subjects? Is it only for a small sample? Is it sample standard deviation, or is it all standard deviation? You see what the way they say it, and the average was 330, and their standard deviation, so the there is referring back to the sample. So it's a sample standard deviation. So in this case, we're going to use a t-test since sigma is not given. We don't have sigma, and in this case, we can't really use z, we can only use the t. State the hypothesis to be tested and define the parameter. Use a two-sided alternative. Okay. So you have H0, HA. This chapter is paired sample. Reason is you have one sample performing two tests. So one population performing two tests. So the 16 subject, we measured 1 week of food consumption and then again at a higher food consumption. So it's the same group doing two tests, before and after. So in this case, and since you know that this is per sample, you say mu d equals 0, mu d not equals 0, since they want you to do it as paired sample or mu d. And then you define what mu d is. Population mean difference in, this is the mean in what? In calories per day for all subjects consuming base food for 1 week, that would be group number 1. And consuming a higher food consumption level. Consuming base food consumption level for 1 week and consuming a higher level food consumption level. So again, it's the mean of what and what the sample is, and defining the two groups or the two tests involved. One test was base food level for 1 week, and the other test was a higher level. Okay, this is your mu D. They tell you you get a t-test of 2.C. You get a t-test of 2.721. State the degrees of freedom, find the p-value in the appropriate table. So we need to find the p-value in the table. Okay, degree of freedom, n-1 in this case. For this chapter, your degree of freedom is n-1. So 16 minus 1, 15. And to get a p-value, t, as I mentioned before, you need to know your DTT, degree of freedom, test, and tail. Degree of freedom is 15. Test, they provided the test, and it's 2.721. And since you're not equal, it's 2 tail. So I go to my t-table from the internet. So the degree of freedom is 15. Now I look in the line for degree of freedom 15. Where do I see 2.721? I see it between 2.1 and 2.6. I go up to the 2-tail percentage. I'm somewhere between 2% and 5%. So between 2% and 5%. Again, I don't know what t-table you're using. I'm basing this on the blue t-table. So your t-table could be a little bit different. Your t-table could only be like a one-tail system. So when you go to the degree of freedom 15, and you see where the number is, like it's between two different numbers, you go up. If you see 1%, that means that your table is one tail. If you see 2 lines, one of them would be for 2 tail and 1 tail, so it'd be easy. Just pick the 2 tails, so you're between this percentage and this percentage. If you have a t-table with 1 tail or 1 line percentages, that means it's only 1 tail. So once you know what 2 percentages you're between, but you have a 2-tail system, you need to double it. So that's if you have a 1-line system. If you have a 1-line t-table, then you say we're between this and this, but since we're 2-tail, you need to double it. If it's 1 tail, you would just leave it the way it is. Now state the conclusion at 5%. So if your p-value was between 2 and 5, and alpha, they give you alpha at 5%, so we can base the conclusion on significance. We have alpha. So p-value is less than alpha. It's between 2 and 5, so it must be less than 5%. Less than or equal. So again, we are rejecting H0. We're concluding HA. So in English, we didn't talk about the conditions involved, or there was no talk about, and they didn't mention that the fact that the conditions are satisfied. So we say, if assumptions hold, we can conclude HA. But we don't say HA, we say what HA is. We can conclude that. And from here, we can conclude that population mean difference in caloric discount for all the higher people, all of this to the end till you get the word higher. Is not equal 0, meaning not equal 0, meaning different. So we can conclude that they're different because it's not equal 0, meaning that it is different. Now, I'm also going to discuss the assumptions for this chapter. It's pretty much the same assumptions. The assumptions for this chapter, first one is the independence. The sample in the question must be selected randomly. And you'll see there is, again, no mention. They didn't say anything about random selection. So you say, not met the sample of 16 subjects was not selected randomly, not mentioned in the question. The other assumptions is normal, probability, condition, or assumption. You need histogram, you need probability, again, no histogram, no probability plot, not mentioned in the question, so sample size assumption must be checked. So sample size. Sample size assumption, your N is 16, that's level 2, between 50 and 40. In this case, if you're between these two numbers, you can allow for a little bit of skewing with no gaps or outliers. So data can be little skewed with no gaps or outliers. But we don't know. But we don't know. They not mentioned in the question, no histogram given, condition not met, or cannot be assessed. And the last condition, or the new condition for this chapter, is paired sample condition. Do we have paired? Yeah, condition here is met. We have one sample of 16 subjects performing 2 tests. And you can mention what the 2 tests are. So one is consuming the base food level consumption, and the other one a higher food consumption level. Now this is it for question number 2. For this chapter, I also, for chapter third sample, look at the assignment. The assignment, they provided some good questions in the assignment. So if you have the answers for the assignment, look at it. If you don't, I can send you the video I did for this chapter, but the question, the assumptions were good. This one is good, but no mini-tab provided. So it was hard to do it. I wanted to do it like confidence interval as well, but I can't because there's no mini-tab provided. So we'll stop at this, and in the next part I'll continue with the other questions.